Hi, good day everyone. On behalf of Group 1, I'd like to quickly introduce myself. I am Cadet Kabanday and my group members are, first of all, my apologies if I mispronounce the last name. So, my group members are Cadet Abadiano, Cadet Abarcus, Cadet Anhao, Cadet Aum, Cadet Bacalso KJ, Cadet Bacalso Rins, Cadet Buruk, and lastly, Cadet Buruz. I hope you all doing well, and today's video is gonna be about different principles in ship handling and significance of deadweight, draft, trim, speed, underkill, clearance, turning circles, and stopping distance in a ship handling. So let's get right into the video.
Effects of external forces. The effects of external forces may become advantage or disadvantage to the ship handler. It is best that these effects are foreseen beforehand so that necessary steps to counter or make use of them during the maneuver or made, as some experts put it, the art of ship's handling involves the effective use of forces under the control to overcome the effects of external forces. Among the external forces are effects of wind and current are the most important. These forces greatly affect the movement of ships. When there is wind blowing on the one side of high-sided ship moving ahead, she will not move along the line or intended course line, but rather drift towards the lee side of the ship. Always bear in mind that current affects ships more than the wind. Our allowance made of compensate for these factors are called set becomes. Generally, it is not possible to separate the differences. Other variable factors of affecting ship handling. Human factor, a delay in a time between your given order or execution of orders will affect how you intended to move your ship. This is caused by human factors because the individual you are ordering may have different responses depending on their training and ability to perform the job, or that order have to be relayed by a officer of the helmsman, which is bad practice that should be avoided, so that the coming officer should be able to give his order directly to the helmsman. Suddenly, breakdown failures of the ship equipment. Mode of communication failure from the bridge to engine room or vice versa, or the force of the or to the fore or aft situation. Language problem between nationalities and ship momentum. Thank you.
Good day, sir, and good day, classmates. Today, I'll be discussing different principles in ship handling. So, there are 7 principles in ship handling. First is deadweight, draught, trim, speed, underkill clearance, turning circle, and lastly, stopping distance. So, first is deadweight. Deadweight is the actual amount of weight in tons that a vessel can carry when loaded to the maximum permissible draught. Includes fuel, fresh water, gear supplies, catch, and crew. Second is draught. The draft or draught of a ship's hull is the vertical distance between the waterline and the bottom of the hull. The more heavily a vessel is loaded, the deeper it sinks into the water and the greater its draft. Next is trim. The trim of a ship describes its floating position in length, direction, namely if the bow or the aft of the ship is deeper submerged into the water. The trim can have a significant impact on a vessel's energy demand for propulsion during sailing. Next is speed. Knot in navigation, measure of speed at sea, equal to 1 nautical mile per hour, approximately 1.15 statute miles per hour. Thus, a ship moving at 20 knots is traveling as fast as a land vehicle at about 23 mph or 37 kilometers per hour. Next is underkill clearance. Underkill clearance, or UKC, is the vertical distance between the lowest part of the ship's hull and the seabed. Maintaining a minimum UKC is essential for the safety of navigation. Static UKC is the minimum clearance available between the deepest point on a vessel at rest in still water and the bottom. Next is turning circle. So the turning circle is the path of the ship's pivot point as it executes a 360 degrees turn. In shallow water, the rate of turn is likely to be decreased, so the vessel will have a larger turning circle. And lastly is stopping distance. Stopping distance is the distance which a ship will continue to move after action is taken to stop engines until the ship comes to rest. Stopping distance details may be provided for sea speed, harbor speed, half speed, etc. So that's all for the principles in ship handling. Thank you.
Good day, I'm Decadet Alengato, and I'm here to talk about dead weight. Dead weight is the actual amount of weight in tons that a vessel can carry when loaded to the maximum permissible draught. It includes fuel, fresh water, gear supplies, catch and crew. So the dead weight is the total weight of cargo that a ship carries or can carry at a particular draft. That's all, thank you.
Hello everyone, I am Dekadita Thailandha. For today I'm going to discuss about significance of drop. So deep drop refers to boat that sits much deeper in the water. Also, a boat with a deep drop will have a hull bottom that sits lower in the water than a shallow drop boat. The bottom of this will not always be the boat lowest point.
Good day, everyone. This is Cadet Bakal Christian James, and I'm here today to report about the significance of speed in ship handling. So, ship speed plays a very important role in ship handling because to know how the ship will move the way the ship handler wanted to. Speed of a ship depends on a various factor like displacement of vessel, draft, wind force, and direction, sea weather condition, condition of the hull, and the propeller, and so on. So for an empty ship which has no cargo loaded, displacement is less and hence the drop is less. There is less resistance as the lesser surface of the hull is in contact with the water, and as there is not much load on the main engine, it gives more speed at less power. Whereas for a loaded ship, the drop will be more and thus the ship resistance against the hull. Also, for the same power of the main engine, the ship will have lesser speed as the load on the main engine will be higher. It has become necessary to know the importance of regulating ship speed and how ship speed is measured. An efficient regulation of the vessel speed and good knowledge of different speed of different vessel and reason behind them is necessary not only to know follow rules and regulation of international convention, but also to know make the vessel economical for the operator in the best possible way in order to have a good ship handling and make the ship environmentally friendly and for safe navigation. And that's all And thank you so much.
So, hi everyone, my name is Decadet John Lawrence Bacaso, and for today I'm going to talk about the significance of underkeel clearance in ship handling. So, in the underkeel clearance is the vertical distance between the deepest underwater point of the ship's hull and the water area, bottom or ground. In ship handling, it is very important to calculate precisely the underkeel clearance requirement for the vessel and ensure that the vessel remains afloat at all times. Knowing if the depth of the water will ensure that the hull won't be damaged or accident won't happen. So example, if the vessel is traveling, you have to conclude you have to conclude or mark the route that you're going to go, the route, and make sure that your ship will have the sufficient underkeel clearance requirement so that your ship can maneuver to that particular area safely, or it won't the hull ships won't be damaged because it won't reach the ground because you have the sufficient underkeel clearance. So another term, knowing underkeel clearance is very important so that accident and damage to your hull or the vessel won't happen. So meaning it is a very important it is very important to take note the underkeel clearance, especially in passage planning. So thank you for listening. This is Cadet John Lawrence Bacal.
Hi, good afternoon. I am Cadet Borok. I am here to discuss about the significance of turning circle. So, what is turning circle? Turning circle, when a vessel is made to turn under a continuous helm through 360 degrees, it will follow a roughly circular track called turning circle. Second, advance. It is the distance traveled by ship along original course line when she alter her course through 360 degrees. The third is transfer. It is the distance traveled by the ship measured from original course line to the point when she alter her course by 90 degrees. Fourth, tactical diameter. It is the distance traveled by the ship measured from original course line to the point when she alter her course by 180 degrees. Last is drift angle. It is the angle between the ship fore and aft line and tangent drawn to the turning circle. That's all. Thank you.
Good day everyone, this is Deck Cadet Martin P. Bustamante and I'm going to report stopping distance in ship handling. What is stopping distance and how many stopping distance are there? So stopping distance is the distance covered by a ship after the engines are stopped. So but pasabot, mao ni siya ang imong making headway from pagsugod na gi-stop ang engine. So, there are two types of stopping distance. So, number one is inertia stop and number two is crush stop. Inertia stop. So, inertia stop, when the engine of the ship is stopped, the ship will continue moving in the same direction for some more distance due to inertia. Here, no astern command is given and hence ship will travel more distance in the initial stop method. Next is crush stop. Here the engine, which is moving in an ahead direction, is given an order for full astern, leaving the rudder in the midship position to stop the ship within minimum distance in shortest possible time.